Hello guys, welcome back to Infinite Insight Geometry, Lesson 1.8, Two-Column Proofs. Alright, let's begin. So, in proofs there are two main pieces of information, two columns of information that we have to give to prove a statement. There are, the statements, of course, the steps that we go through to reach the conclusion, and the reasons those steps are true. So for every statement, you also have to provide a reason. And that will be our foundation in which we prove more statements until we eventually reach the given conclusion. These statements and reasons can be put in order, in a logical order, in a two-column proof, with the statements in the left column and the reasons in the right column. So here's an example of a two-column proof. Now, I want you to look at the reasons column. You have the given statements, you have the definitions, you also have a definition of the right angle, you have a definition of congruency, definition of complementary angles. Those are all definitions. You have properties, the transitive property. There's also the symmetric property, or the identity property, or the addition property of equality. All of these are properties of numbers, and we can use these properties of numbers in geometry because they are also math. Now, I want you to look at the reason for number 3, the angle addition postulate. These postulates and theorems are what we use to also prove these statements. Now, given that this is just a lot of mumbo jumbo for you, I have a diagram. It's helpful to draw a diagram of a problem, especially if you are not given the diagram in the first place. Sometimes you're just given a word problem. Sometimes the diagram is even given for you, and you can just get what you know from these diagrams. You can see that the angle BCD is a right angle because there's a square in the middle of it. You can also see that angle 1 and angle 3 are probably congruent because they have the one line. Over the course, we will see what all of these symbols mean and what they do. But I need you to remember that sometimes diagrams can be misleading. Something that looks true isn't necessarily true, as with real life, of course. But that's also especially true in diagrams. Just because something looks like a right angle or something looks like a triangle, it doesn't mean that it is a right angle or a triangle. It just looks like it. If you want to state that it is a right angle or a triangle, you have to prove it first. And maybe that will help you reach your given conclusion that you need to prove. So, here's the diagram along with the two-column proof. In this two-column proof, we have to prove that angles 1 and angle 2 are complementary, and they did it as so. They used the definition of a right angle, the angle addition postulate. They used the definition of congruency and substitution to mold all of these together and put them in a logical order to make a two-column proof. Now, some common mistakes. You have missing reasons. Everything has to be stated in the proof. All statements have a reason. The reason for the given statements is just given. You're just given the statements, so you don't really have to prove it that it's true. It's already given for you. The second mistake is circular reasoning. Every statement should be reasoned with a given statement, a definition, a property, a postulate, or a theorem. There's also substitution. But the key thing here to note is that every statement, every building block, every step that you need to take to reach your given conclusion must have a reason, which is a definition, postulate, theorem. And the third mistake is skipping steps. Now, if you need a right angle to prove that two angles are complementary, you want to prove that there is a right angle first. If you're not given the right angle and you want to use a theorem about right angles to prove that those two angles are complementary, then you first need to actually prove that it is a right angle, because you cannot prove something is complementary if you don't have a right angle. Make sure you prove everything needed to move on to the next stage of the proof. And that will be all for today's lesson. If you like the video, please like, subscribe, and comment. I have my Gmail down below in case you have any questions, and I will see you next time.